Hello, welcome to this class. Today I'm going to show you simple steps to balance any chemical equation. I mean it when I say any. Is that okay? So stay till the end and you would not have any problem again with balancing chemical equation. Alright, let's dive right into it. Okay, first thing first, before I show you how we can balance these chemical equations, there is something very important you need to know. What is that? Why? The why behind balancing chemical equation is very, very important. If you know it, you have already known the basics of why we balance chemical equations, and I will tell you why then we balance all these chemical equations except these last ones. I will tell you what we will do with them. All right, so let's balance. If you observe, I arranged them from simple to complex ones so that you would see how to balance any kind of equation so far. So stick to me so that you master this case once and for all. Thank you once again. So let's dive right into it. Why do we balance chemical equations, by the way, you ask? Oh, all this stuff all the time, balancing chemical. Why do we do that? Alright, I want to remind you of a law of conservation of mass. Conservation of mass of matter. Let me use this. Do you remember that? Matter can neither be created nor destroyed. Do you remember this law? Very important. Now, what is this trying to tell you? It is trying to tell you that nothing on earth can be destroyed. Let me give you an example. Let's say you burnt a paper. This is your paper, right? Then you set it on fire, flame, and it burns. Excuse me, what does it turns to? Ash. You got it right. You got it right. What is this law trying to say? It is trying to say that if you can gather all the ash, are you with me? If you can gather all the heat that escape, if you can gather all the smoke that escape in form of either carbon dioxide, carbon monoxide, and put them together and weigh them, their weight will be equal to the weight of the paper you burnt. Have you ever thought of this before? So that's what this law is saying, that nothing can be destroyed. The equal amount of paper you burnt, if you can gather any other component that went out during the combustion process and weigh it, it will be the same. So did you destroy the paper? Nope. You only succeeded in changing it from paper to heat, carbon monoxide, and ash. I hope this is clear. So that's how we balance chemical equations. Hence, what we are trying to say is that anything you get from the reactant side is equal to what you would have at the product side. What we have from the reactants must be equal to what you have at the product side. So that's what this law is telling us, and it's just very simple. So I'm going to explain how we are going to balance, how you would balance any chemical equation easily and in a very simple way. Alright, are you ready now? Let's go. Okay. Alright, so let me clean this side so we could have a space to work with. After this class, believe me, you will be able to balance any equation. So the first in the list is hydrogen plus oxygen to give us H2O, which is our water. Now, this is very important and you need to get something from here. There are two methods. I want you to master both. If you master both, you don't have any issue. So the first method is by brainstorming. You brainstorm, of course, and you come up with numbers that would give you the balance from the reactant side to the product side. So the second method is using algebraic formula. This works for every kind of equation also, and it's very accurate, no problem, doesn't have any issue. So let's start with the brainstorming. So by brainstorming, of course, like I said earlier, that your reactants must be equal to your product side. So let's look at the first thing is to write your unbalanced chemical equation. The second thing is to count, and the third thing is to balance one element at a time. How many steps did I mention now? Write your unbalanced chemical equation. Yes. Count the number of atoms in both reactants and products. Yes. The third one is what? Balance. Then you balance one element at a time. In fact, you should start with an element that appear in fewer compounds. This will make your work very easy. It won't complicate issues. It makes it go faster. When we are solving, I will try to make sure you get this. Alright, so let's count now. Having write an unbalanced chemical equation, of course, what's the next step? We should count, of course. So this is reactants. These are products. Okay, so at the reactant side, hydrogen is equal to 2, oxygen is equal to 2. At the product side, hydrogen is also equal to 2 atoms, oxygen is equal to 1 atom. Yes, if it is 1, it is usually omitted. Now, permit me to also say this very, very quickly. These numbers that you are seeing under or by the side here are referred to as subscripts. Now, this number, okay, let me use this example. This 2 is for hydrogen only. Now, look at this. If I now write somewhere 2H2O, what does this mean? This is referred to as coefficient. Please get this. These terms are very important. Coefficient, subscript, they are not the same. And each has its own role. For example, in this case, this subscript is for hydrogen only. Meanwhile, this coefficient is both for hydrogen and oxygen. That's why it is written in front to say, I am for both hydrogen and oxygen in that compound. Please note the difference between the two. If that is taken, let's continue. So, observe that every element also in every compound has a subscript. If it is 1, it is usually omitted. For example, oxygen here has a subscript. Of course, we know that this 2 is for hydrogen. Oxygen too has, of course. And what's the subscript? It's 1. But when it is 1, it's usually omitted. But 2, 3, you write them down. I hope that my explanation is clear. So having said that, reactants, products, what's the problem here? Hydrogen, balanced. Oxygen, not balanced. How do we balance this? We have to make this oxygen 2 and the other side 2, if it is possible. So this is already 1, this is already 2. So how do we make this 2? Now, in balancing, you are not permitted to add a subscript. This is the mistake that many students make. You don't add a subscript. You add a superscript. You add a coefficient rather. So in this case now, we are going to add a coefficient. To make oxygen 2 here, of course, we have to add a coefficient. So that coefficient shows that this 2 is for both hydrogen and oxygen. So now our oxygen is 2 here and our oxygen is 2 here. Oxygen has balance. But because we wrote 2 here and this 2 is for both hydrogen and oxygen, you can now see that the number of hydrogens in the product side has changed. Are you getting it now? It has now become 4. Because 2 times 2 is 4. So what do we do? Now, to balance it, we quickly balance hydrogen in the other side. Because it has changed to 4 now, so it has to change to 4 also this side. How do we make this place 4? We also add a coefficient 2. This makes it 4. 2 times 2, 4. 2 times 2, 4. Hydrogen is now 4 at the reactant side, 4 at the product side. Oxygen is 2 at the reactant side, 2 at the product side, because this 2 is for oxygen too. Is this clear? So in this case, this equation is now balanced. Anytime you are done, cross-check to be sure. So at the end here, we have hydrogen to be equal to 4. At the product side, also hydrogen is 4. Oxygen at the reactant side is 2. Oxygen at the reactant side is also 2, showing that our equation is balanced. Let's quickly go to another one. Very quickly. I'll be faster this time around. I want to go to the next method, so I won't take much time. So our second question says sodium plus chlorine to give sodium chloride. Yes, what's the problem here? 1 sodium, 1 sodium, 2 chlorine, 1 chlorine. So we have to make chlorine 2. Let's add 2 here. So 2 chlorine, then we have 2 sodium atoms here and 1 sodium atom here. Because we try to balance chlorine, then the number of sodium has increased, so which means we have to also settle this. So how do we balance it now? We make this place 2. 2 atoms of sodium, 2 atoms of sodium, 2 atoms of chlorine, 2 atoms of chlorine, equation balance. Is this not simple? This is using brainstorming. We are coming to another one. Is some complex chemical equations. If you want to use brainstorming, oh my god, you will take a lot of time, trial and error. But once you know also that algebraic method, it's going to be very, very helpful. Alright, so let's go. Next one is combustion of methane, CH plus oxygen, to give us carbon dioxide and water. Sorry, this place is not enough. Let me increase it here. Methane plus oxygen gives carbon dioxide and water. Okay, is this balanced? Always before you check, first check to be sure whether it is balanced. How do you do this? Count the number of atoms in the product and reactants side. So here we have reactants, we have products. How many elements do we have? Carbon, hydrogen, oxygen. Carbon, oxygen, hydrogen. So we have 3 elements in this case. So what do? We have carbon. How many do we have on the reactant side? Only 1. Then what of hydrogen? Hydrogen, we have 4 atoms. Oxygen, we have 2. What do we have here? Carbon, also 1. Hydrogen, we have 2 here. Oxygen, we have 3. We have 1 here and we have 2 here, making it 3. So in this case, carbon is balanced, but hydrogen and oxygen are not balanced. So we start with hydrogen first. Now, in any chemical equation that involves organics, please balance carbon first, followed by hydrogen, and then lastly oxygen. The reason is because most times when you balance carbon, hydrogen will automatically balance in some cases. The same thing. So you will reduce work. It will make the work easier for you and simpler. Alright, so let's go here. What do we have? So how do we balance this? Hydrogen is not balanced. Here is 4, here is 2. So let's add 2 here. 2 times 2, 4. We have 4 here. So hydrogen is now balanced. Carbon is still balanced. It's not affected by the changes we have made. So let's now balance oxygen and see what we have. So here we have oxygen 2. Here we have 2 and we have 2 here, making 4. So we have to make the reactant side 4 too by adding 2 here. So that 2 times 2 will give us 4. Is this clear? So you can now see that carbon 1, hydrogen 4, hydrogen 2 times 2, 4, oxygen 2 times 2, 4, oxygen 2 here, making it 4. Balanced. I hope this is clear. Alright, I said I won't take much time. I want us to be fast and finish. So let's quickly go to the next one. Oh, the next one is also simple. Aluminium plus oxygen to give us aluminium oxide. Yes, so this is another one. How do we go about this? Now, let's still use brainstorming method to work it out. So from here already, sometimes or in most cases, once oxygen is in what do we call it, odd number, you have to make it an even number. Once it is an even number, it becomes easier for other sides to balance. For example, okay, let me use that way. We will not get it, but later we'll come and get it. Let me show you. If we start balancing aluminium, what will happen? Assuming we start with aluminium, so this is 2. Aluminium 2, aluminium 2. Now, look at oxygen 3, oxygen 2. How do we balance this now? Do you get what I'm trying to say? So to make it easier, make this oxygen become even number, then balance other side. So what do we do in this case? In this case, we are going to say, let's add 2 here, so that this will become 6 now, and this will become 4. Are you getting it? 2 times 2, 4. 3 times 2, 6. So here now at reactants, now at products, we have aluminium to be 4, oxygen to be 6. So let's balance this side too. How do we make oxygen 6 here? We add 3. 2 times 3, 6. Balance. Oxygen is balanced. Aluminium, how do we make it 4 here? Add 4 here. Equation balanced. So we have 4 aluminium atoms, 4 aluminium atoms, 6 oxygen atoms, 6 oxygen atoms. Equation balanced. So let's now go to the bigger one. Yes, we cannot use brainstorming method here, because if we want to use brainstorming method here in this kind of equation, you know what will happen? Hey, this may take us up to 30 minutes, but we are not going to. That's why I promise you that I'm going to show you shortcut ways that even your tutors don't usually tell you, so that you would know the secret of balancing these chemical equations very easily. So this is 2. Yes. So look at the chemical equation we have at hand now. Look at it carefully. So if you now start saying, oh, let me balance this, iron is 2 here, iron, let me put 2 here, carbon is this, it will take you a lot of time. You know why? Because as you balance one, another one becomes offset, and we have compounds that are a little bit complex. So what method do you apply? You apply algebraic method, and this algebraic method can work for the previous ones we solved too. You can try it later to confirm what I'm saying. So we use algebraic method. So how does it work? You assign coefficients in form of letters, and then you bring out equations for each of the coefficients, for each of the elements. It is very simple, please. It is very simple. Just follow me and you will see what will happen. So what that means is that I will say A, B, C, and D. First step. Second step, observe how many elements do we have? We have iron. We have oxygen. We have carbon. Do we have any other element that has not been captured here? Nope. So now, after writing out all your elements, since we say this algebraic method is also trying to say what is this side must be equal to what is in the other side. So that's how it works. So having bring out all our elements, let's now form the equation. So the equation is this iron. Now we want to form the equation for it from the reactant side and the product side, and we are going to equate the two. Very simple, just follow me carefully. So here now, iron is 2. Usually we say 2 times this, coefficient times this, to give us the number of atoms, isn't it? So for iron we have 2A. Do we have any other iron now? No. Then product side, we now say it must be equal to C. Very simple. What we are trying to say is that the number of atoms for iron in this side must be equal to the number of atoms of iron in the other side. Simple. Okay, so the next one is oxygen. So for oxygen, remember, coefficient affects everything in the equation, in the compound. So this A is also for oxygen. So for oxygen, this will be A, 3A, because 6 times A is 3A. So we have 3A. Do we have oxygen here again? Yes. Plus B, because B is for carbon and oxygen, okay, is equal to, where do we have oxygen here again? Here we have oxygen, and it's 2 here, so multiply by the coefficient, it will be 2D. This will just give you accurate result once you get it, and it's very simple. Okay, so we are done with that. Let's go to the next one. The last element is carbon. Carbon is B here. Is equal to, because we have only one here, no plus, is equal to D. Very simple. I hope this is clear. Is it clear to this point? We are just trying to say the number of atoms of iron in this side must be equal to the number of atoms, the number of oxygen equal to number of oxygen, number of carbon equal to the number of carbon in the other side. Once you have done this, now pick any of the letters and make it 1. So let's say, let A be 1. Simple. So work this equation out. So for iron, it will give us 2 times 1, because we are now saying A should be 1, is equal to C. What this means is that C is equal to 3. Are you seeing how we are getting our coefficients easily? So it means that this C represents 3. Very simple. Now let's go. Let's go to oxygen now. Oxygen, we have 3A, so it will be 3 times 1 plus B is equal to D. Now I will do something very important here. Remember, B is equal to D. So if B is equal to D, it means that I can remove D and replace it with B so that I can solve. So this gives us 3 plus B is equal to 2B. Because B is equal to D, from here, B is equal to D. So I can use any of them. Any of them. I can decide to use B, I can decide to use D. So I'm replacing D with B to make the letters become equal so that I can solve it. So from here, I would have 3 is equal to 2B minus B. As usual, if I move this to the other side, it will become minus because it's crossing equality sign, just like in our normal mathematics. So with this now, you can see that B is equal to 3 because 2B minus B is B. So our B is equal to 3. Very simple. So from this point now, our A is equal to 1, B is equal to 3, C is equal to what? What's our C? From here, we have solved for C here. C is equal to 3. And our D, we say B is equal to B. So D is also 3. So we have found our coefficients already. So this is our equation will now, balanced equation will now be like this. 3 plus our B is 3 also, to give us our C is 3 plus our D is also 3. Simple. So if you can check it, you would also see that the equation is balanced. Here we have how many atoms of iron? How many do we have? Okay. Sorry, I need to check this. It's not balanced, so we need to check it carefully. Because we have, okay, sorry, I'm the one that made the mistake. Our A is 1, so it's supposed to be here. A is 1. A is 1, so it's usually omitted. A is 1 is usually omitted. A is 1 is usually omitted. So you can always check to prove or to ensure that your workings are correct. You can also use the brainstorming method that I have said. So that's that with this class, and this is assignment. I would like you to do this assignment and send it to me, then I will check it. Thank you so much. We'll meet in the next class. Bye.